I started now. Let's start solving. I'll share on Discord. Screen visible, YouTube stream on, everything good? बोल दो भाई.
Yes.
Good, perfect. So now A, you're given A coins and you can deposit in a bank. Whatever B comes as like the number of coins greater than equal to B. Okay. Now, like if you can't, you deposit in the unprofitable bank, and basically it decreases the deposit like the B value by 2 into X, and you can't use those coin later. Overall, in general, question is let's say 5 and 7 you have. This is the coins you have, and this is the bank requirement. Okay. If I can't directly deposit, correct? If I remove one coin, I deposit one coin away. So what happens? I've left with 4, and this becomes 6. Sorry, 5, because 7 minus 2. Now same thing, if I deposit 2 coins, I'm left with 3, and the bank thingy becomes 3. And this I can do. So this is my answer. Same goes for, let's say I try for 4, okay? Let's say I deposit 3 coins, I'm left with 2, and this becomes 1. This is also valid. This is also valid. This is invalid. Basically, what is happening is there are, let's say, uh, A, let's say 0, 1, 2, 3, 4, 5, 6 till A. Okay, till C. That is the number of coins you can deposit in the unprofitable bank. Now, corresponding to each, there'll be a value. What is the value? If I deposit this amount of coins to unprofitable bank, can I can I basically deposit the number of remaining coins in the profit bank? Here it is. So this is X, this is Y. Y is basically number of coins I can deposit, or if I can deposit. So what is happening is, in this particular test case, all of these pass. And if you see, this is basically a separate search space, linearly separable search space, and that's why you can do binary search here. If you go on iterating, the problem is this is 1e9, and let's say my A equals 10 raised to 9, not 9, huh. A equals, let's say 1000, B equals 10 raised to 9, it most probably will give TLE, like if you iterate for every single person. Iterating will just lead to TLE. That's why we do binary search. Binary search, what we'll do is basically we have left and right? Left is what I assign 0 coins to unprofitable, and right is I assign all the coins to the unprofitable bank. I don't know, whatever is possible. Now from here, simply do binary search. And I'll just come to the code so you can see. Profitable. L equals 0, R equals C, my midpoint. Now, when can I deposit in the profitable bank? When my remaining coins is greater than equal to profit. So remaining coins is what? Total coins minus how many ever I'm leaving in the unprofitable bank, and the amount of reduction is b minus 2 into mid. And since LR, if this is my midpoint, that means all of these are going to be correct. So I can change my R to here. That's why I'm doing R equals mid. Or else, if I'm here, I can remove everyone from my answer and L comes in. That's it. L equals mid plus 1. And my answer is basically this is the L is the number of coins I've deposited in the unprofitable bank. Whatever is remaining is my number of coins I deposit in the profitable bank. That's it. Any doubts? Yes, no. I'm assuming no. So let's move on to B. B, there are coins and there are slots. Each slot has a button and like you don't know how many slots are remaining and you don't know the mapping basically. Let's say I have a vending machine. This is X. I know the initial number of coins. Let's say 1, 8, 2, 3, and 4. This is my initial configuration I know. But I don't, these are the buttons. I don't know what is the mapping to it. Like if this is mapping to 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 this. I have no clue. And what I need to do is by pressing the buttons n number of times, I need to get k cans. Like this is basically a black box. I can't see basically. So if I press a button, a can comes out. I have no clue which slot the can came out from. Okay. It can come from here, it can come from here, it can come from here. But I know for sure that if there is no can, I know that that button is just empty. So what is the approach and how do I go by it? Let's just say this entire thing I can basically, let's say k equals 10. Okay. Now, firstly, since my n equals 5, I'll assume I'm taking out two cans. Like I'll press two buttons and I can take out two cans. Because if I distribute evenly, that is 2, 2, 2, 2, correct? Let's give it, let's give a little bad example. 9. Now, what I want is 3, 3, 3, 3. Wait. Ah, 2, 2, 2, 2, and 1. If I distribute like this, then I can get my total value as 9. So this is the number of presses I need. Let's say after doing these first two presses, I realize ki, bro, I am getting one can. Let's make it wait. 3, 3, 3, 3, 3, 3, 3, 3, 3, 2. I have no clue what is the mapping. I don't know how many cans are left in a slot, but this is how many times I'll press a button. Okay. Now pressing the first button, what is the worst case? That my button itself, like my minimum cans wala button is mapped. A slot is mapped to this button. Correct? Yes, no. That is the worst case, right? At the end, I have to print guaranteed at least k it can in the button in the button presses. So let's say all three buttons, like I am like basically let's say it is this mapping here, this mapping here, this mapping here, and this mapping here. This is the worst case. Now, when I press it once, I get a can. When I press it the second time, I don't get a can. Will I press it the third time? Yes, no. Hello.
No.
Exactly. So I'll just move on, correct? Let's say I get one can out. Hmm. So now after the first button, I got one can. What is the remaining? There were 14. Okay. Since I've gotten out one can, there are 13 remaining ones. Now I need to distribute equally once again among four. So what will happen? This is what. Let's just sort it this. Worst case is this. 1, 2, 3, 4, 8. Now since I have 13 cans and four slots, four buttons, what will I do? 5, 4, 4, 4. This is my imaginary button pressing. Okay. Now same thing after I'll get only two cans, correct? And I have two presses here and I get three presses because after the third press I know okay, this button, this slot is empty. Fair enough? Hello.
Yes, yes.
Huh. Now I've removed three cans. So what is the new assignment? Total 12 and remaining equals 3. So it is basically 4, 4, 4. Huh? Wait, I'm missing something. This was 13. 13 divided by 4 is 433. Ah, my God. Stupid. This was 4, 3, 3, 3. Now the next assignment is 4, 4, 4. Now once again, if I see that I'll get only three cans out of this, correct? This is the mapping. I'll get 3C. And how many button presses I took? 4. Yes. Yes, no. Hello. Huh. So that's it. Like you basically keep assigning these values. But now I can't basically manually assign, right? Because let's say after for let's say this is the first assigning 3, 3, 3, 3, 3. Second assigning, let's say I update all the values. Let's say it is 4, 4, 4, 4. Third assigning, let's say it is 5, 5, 5. Second, last assignment is 5, 6, 6. And let's say this assignment is 7. This is too much time and space, like basically around n square only, which will not work. So that is where you do some magic and basically come onto this like code. Say I'll explain. It's like pretty easy to understand from this. If you have any doubts, just ask me. So now, firstly, the sorting by the values because that is the worst case. Wait. Ah, fair. You can do it mathematically also, but binary search just came to my mind. So yeah, good. So huh. Firstly, the worst case is when it is sorted, because how many buttons I'll press, I'll have to waste now n number of buttons, right? Like how many presses I'll get to reach here. Fair enough? Yes, no. I'll have to waste some button presses. The number
Yes.
of wastes I have to calculate. I have done it in a bit roundabout way, but yeah, fair. So now, firstly, so for every single value, I'll just divide k by n, right? This is my initial assignment, all threes. Wait. Hmm. It is 2 to 2 currently. The addition part I'll come to later. And number of operations and number of remaining slots I initialize with 0 and n. For every position in A, what is this? So let's say I have k equals 14 and n equals 4. Huh. So basically, if I just divide normally, if I do floor division, what do I get? 3. So what happens is I assign 3 to everyone. Now the extra operations is what? How many operations are left? How many cans are left basically? 14 mod 4. Yes, from the division. Yes, no.
Yes.
Huh. So that is 2. So basically what I need to do is I need to give 2 to the first two indices, right? Huh? So that is this. If my k mod remain is something, that means I need to have one more button press, right? Hello.
Why? Can you explain?
Huh. So by doing floor, I've assigned 333 here. Fair.
Uh,
Now the sum of 3333 is what? 12. I have two cans remaining, right? Those
yes.
two cans I need to do plus one here and plus one here.
Hmm.
Fair. So now since I'm at the first place itself, if my k mod remain is something, I'll add that to plus one, right?
Yeah, yeah.
That is it. The
Yeah.
per is basically total division, and if there is any remainder, I add another one to it. Okay, that is my number of button presses. If my current like the number of cans is only less than the number of button presses, so what will happen? I'll do I plus one operations, because at the I plus one of the operation, I'll know okay, this is empty. Fair.
Yes.
And I'll remove, and the number of cans I get is I, so I remove I from k. I
Hmm.
also decrease the remaining because I have one less remaining slot left, button left, and now I redistribute the per basically. This is my redistribution. This thing from 4333 to 444. That is my redistribution. Fair enough. The remaining k by the remaining slots. Simple. Fair. Hello.
Yes.
Huh. Now the other part is else. Else meaning what? I have something greater than equal to the k value, right? Greater than equal to the per value. Let's say it is I have 4 and I require only 2. So what will happen? I'll take 2 cans away. Simple. Fair enough. So whatever the requirement was, required number of dresses, I'll get that many requests, right? Okay, what is this? I'll explain it. Wait. Huh. So this is the number of presses. This we figured out. So that number of presses I require. If my cans are greater, I'll press all the buttons. I'll press it that many times, right? I'll get that many times of cans. Fair enough. Hello. Wait. Presses equals per press. Presses. Presses. Fair. Yes. No. Hello. Now
Yes.
since I know my presses are more than sufficient, I just increase that operations and I decrease the k. That's it. Here I don't need to redistribute because I've already assigned 333 everywhere, right? Now if 3 is satisfying, Aage will also be 333 itself. I don't need to reassign 17. So that's the only thing. And yeah, final mein I just print the number of operations. And it up. If you don't understand, please let me know. Bhai.
थोड़ा ओवर कॉम्प्लिकेटेड हो गया.
Okay, fair, fair.
हाँ.
How? Wait, let me look at better solutions. I तो did it.
मेरा भेजू.
मिल जाएगा.
मेरे को necessary.
हाँ, send your code now. Whoever has done it easier way. So I'll explain it better.
Yeah, sent.
Hmm. So you're doing a minus equals sum. Sum is what? How much ever.
हाँ. Like how much ever levels I have reduced.
Fair. And operation is minimum of.
K multiplied k comma a of I multiplied by n1. Like n1 is my n initially, and when I remove my first minimum element, like it gets decreasing.
Let me visualize it better. And, a minus equals sum. Operations is min of k, which is fair, and a of I into n minus into n1. N1 is what?
N1 is initially n, or like जैसे ही as like my minimum element gets removed,
Okay,
n1
you
gets
distributed that way. Fair enough. Fair.
yes, yes.
Huh. I was doing something similar. I don't know why I stayed after this, but okay. Sum plus equals AI. Fair. And if k greater than 0, you do one more operation.
Yeah, like one more button press. I'll need to like confirm that it is
Fair.
empty.
Confirm this is empty, and then do n1 minus minus. Fair, fair. His code is bit lot simpler. Good, good. So what it is doing is 1, 2, 3, 4, 8. Now, this is my worst case, okay? Huh, makes sense. So now let's say 1. I'll do one press for every single one. Like it doesn't hurt me, right? How many ever remaining are there? Fair. Because I know okay, everyone is greater than 0. So I'll press one each time. Like I just pressed all the ones together. Fair. So this will become 0, 1, 2, 3, 7. Yes. Now I need to verify that this is empty. That is where I require one more press. Or else I'll press again, na. Since it's empty, then only I'll move on to the आगे वाला window. So that is what is code is doing. Firstly, whatever the number of cans it has, I'll just multiply it with n1 and obviously minimizing it with k. That is my number of operations. Now I'll reduce this. My sum also reduces by sum is basically how many button presses I've done up till this point. So like here will be one. So I'll pass on one here. Then when I finish this, I'll do three here. Then I finish this. So it will be seven. That way. So that is the sum. And yeah. Here is basically I'm verifying that this is empty. Since this is empty, I'll move on to this part. And this part also same. It just becomes a new question of 2237 with k minus equals 5. So that's it. You just keep doing this and you get the answer. Any doubts? This is very math heavy and implementation shit. This is cleaner, I would say. Good job. Huh. Any doubts? I guess no. So let's move on to C and let's finish this. Cool. So now permutation. Okay. Let me check other submission in this because mine is a bit heavy because I don't have.
इसमें I use custom comparator मतलब yes
Huh.
over complicate था.
It is custom comparator. Yeah.
अच्छा okay.
Huh. But what is the custom comparator? I'll show you. So I have done a lot of extra set here. I don't think it is needed, but yes. So now in from the test case itself in C, I need to reduce the number of inversions, right? From the test cases itself, what is happening is I'm sorting with respect to the minimum element. So let's say it is 2, 3, to the test case. 2, 3, 9, 6, 4, 1, 8, 7. Now, is it better like if I put 1 as the first number, I won't have inversions having 1 later, right? Basically, if I fix the smallest number to be the earliest, I won't have any number greater than me here. Fair. So I'll have the least number of inversions if I just put 4, 1 here, right? Caused by 1. Like, does it make sense? If this is my array, whatever ahead there is, since 1 is my smallest number among here, if I place 1 here, the only greater number is here itself. I won't have any greater number ahead. And आगे whatever numbers are there, I won't have more inversions with respect to 1. Fair? Yes, no? Wait, I'll talk about inversions also, so you have a proper idea. Inversions is basically, let's say I have 1, 4, 2, 1, 3. Okay. Now for every number, the inversions it is present in is basically the number of greater numbers ahead of behind it. How many numbers greater than 1 are behind it? 0. How many numbers greater than 4 are behind 4? 0. How many numbers greater than 2 are behind 2? 1. How many numbers greater than 1 are behind 1? 2. And this is 1. Total number of inversion is basically 4. And in official terms, what the explanation is, let's pick two numbers I comma j. Wait, I and j. Here I is less than j, but ai is greater than aj. This is basically inversion ka definition. So now, if I fix ai, the smallest ai, सबसे पहले, like since aj is compared to the greater numbers, right? Now, since 4, 1, I fix it here itself. I won't have numbers greater than it ahead. Like there'll be no inversion count. Let basically I'm adding, right? If I do 4, 1 here, all the numbers this, this, and this, all of them will be added as an inversion count. Fair? Because one is smaller than every single number. So if I put it here, I'll have too many inversion counts. I just remove this. I place 4, 1 here. Same goes for here 2, 3. Since 2 is the next smallest, then 6, 9, then 7. This is basically sorting. How do you sort it? This is basically a custom comparator. Custom comparator in C++, I will share the code. But my sorting criteria is a minimum of A less than minimum of B. This should be maintained, okay, for all the A comma B's. Now, there is an edge case. Let's say I give you 7, 3, 3, 7. What will your sort function do? It will see minimum is 3. This minimum is also 3. No, wait, not first. Let's just do this 10 and 7. Okay. Both minimums are 3, so I'll just keep it as it is. Sort function 10, 3, 3, 7. Is this correct though? If I do it 3, 7, 10, 3, how many inversions do I get? Just one here. While here there is 1, 1, 1. I have 3 inversions here and 1 inversion here. So this is my edge case. So what is happening is, if these both are equal, then my max should be less, no? Fair enough? Hello. Damn, everyone is dead. Okay. So yeah. So firstly, I'll sort with respect to this. But if min equals min, then I do this. But now here also same thing. If max also equal, so here what you do is simply uh, like prioritize. If a0 less than a1, then keep it that. Like let's have two numbers, two pairs. Okay, 7, 3 and 3, 7. putting 3 7 ahead is more beneficial for me, so I'll give priority to this. And how do I give priority to this? It is basically 3 less than 7. So just come to the code. This is basically the custom comparator. आगे का you don't need to see. So yeah. So firstly, if my minimums are equal, then check the maximum. If the maximums are equal, then if a of 0 less than a of 1, basically if it is 3 7 7 3, this is true, na? So we'll keep it as it is. But if it is reversed, ये false है. So it will swap. That is how the custom comparator and works. So if this is false, it will swap. If it is true, it will keep it as it is. Now same thing. If maxes are different, then return whatever minimum max it is. And if minimums are different, to return the minimums. आगे का you don't need to see. You just need to sort and print. Print is
तूने
basically
किया क्या है? तूने किया क्या? मैं अभी करता
हाँ. So it is just a custom comparator.
हूँ। हाँ।
Minimum of both of them should be less. Like first number should be
हम्म,
lesser than the second number. But if minimums
हम्म,
are same, then check the
हम्म,
maximum. Maximum should be
ओके।
less. If maximums are same, then
उतना ही करना था।
internally it should be lesser. समझा?
हाँ, इंटरनली लेसर होना चाहिए था।
हाँ. So
उतना
that
ही
is the
करना था।
edge case.
हट रहे।
Wait, that is the edge case. Basically, if it is 7 3 and 3 7, any sort function you do, it'll keep it as it is, which is wrong.
मैं कुछ
Now,
अलग ही किया भाई, पर चल गया।
अरे नहीं,
पर कॉम्प्लिकेट।
after that, I also did ulta. Max a sort with respect to min. So I create these two arrays. I literally count the inversions and print the smallest inversion one. I think I always print A, but yeah, I just was paranoid. So I made this inversion ka function. Inversion function, you use Fenwick tree if you don't know Fenwick tree. Fenwick tree or segment tree both work. I do coordinate compression, then just inversion using Fenwick tree. You can just Google it out. You can check my code to see how I'm calculating the inversions. This happens in O of n log n, so time complexity is fine. And yeah, fair enough. Any doubts? I guess not. So let's just bye bye YouTube. Like, share, subscribe, WhatsApp join, Discord join.